Okay, touch it once, absolutely nothing happens. Touch it again, and it slams shut in a tenth of a second, faster than you can even blink. Welcome to this explainer, where we're diving into one of the most unbelievable mechanisms in the entire natural world. We're talking about a plant that literally counts to 5 before it eats you. The Venus flytrap. I mean, think about it. It has no brain, no nervous system, absolutely no muscles, and yet it behaves exactly like a predator that not only senses its prey, but actively thinks about when to strike.
Look, we all know the famous snap of the Venus flytrap, right? 2 touches, and boom, the trap closes. But here is the crazy part that almost nobody tells you, and honestly, the big mystery we're going to unravel today. Closing the trap is only step 2. The plant was counting, sure, but it wasn't finished. By the end of this explainer, you're going to understand exactly how a plant with 0 brain cells keeps a running tally of your touches, remembers them, and decides precisely when to unleash a horrifying chemical cocktail.
So let's set the stage first. Why does a plant even need to eat meat in the first place? Well, it basically comes down to the impossible math of its existence. See, the Venus flytrap grows wild in exactly one place on planet Earth. It's this tiny strip of swamp, roughly 70 miles wide, right around Wilmington, North Carolina. Nowhere else. And the soil in this specific bog is practically starved of nutrients, especially nitrogen. For a normal plant, surviving there is just mathematically impossible. So this plant did something plants really aren't supposed to do. It started hunting animals to balance the equation.
All right, let's break this down. Here comes touch number 1. Imagine a fly landing on the bright pink inner surface of the trap. Inside there, you've got these tiny trigger hairs, maybe 3 or 4 on each side, thinner than a human eyelash. And they are definitely not for decoration. They are highly sensitive triggers. So the fly walks around, brushing against just one single hair. And the plant does absolutely nothing. It completely ignores it. Which, if you think about it, is incredibly strange. We know this plant can move lightning fast, so why on earth is it ignoring a free meal walking right across its face?
Seriously, why ignore free food? Well, the answer comes down to pure economics. Actually, closing that trap is incredibly expensive for the plant. It costs a massive burst of cellular energy, and even worse, a closed trap is totally out of commission. It can't catch anything else while it's shut. If the fly trap slams shut on, say, a single raindrop, or a falling twig, or even just a strong gust of wind, it's wasted precious energy for absolutely 0 nutritional payoff in a starved environment. That is a deadly waste. So the plant refuses to react to just one touch. It demands proof.
This is where the flytrap stops acting like a typical plant and starts acting like something with, well, a nervous system. When that first trigger hair bends, it fires an action potential. And I'm not using a metaphor here. It is a literal electrical pulse fired right through the plant's leaf, biologically identical to the signals racing through the nerves in your own body right now. This spark travels across the leaf and triggers this rising tide of calcium inside the plant's cells. But remember, the plant needs proof. One pulse just isn't going to cut it to trigger the trap. So the plant does something that sounds entirely impossible. It remembers that first touch. The calcium wave released by that first spark acts as a physical memory. It's kind of like water filling a bucket. But there's a catch here. The bucket has a leak in it. Over the next 20 seconds, that calcium slowly drains away. If a second touch doesn't happen before the calcium drains completely, the plant just forgets the first touch ever even occurred. It's literally a short-term memory timer, running perfectly inside a leaf.
And this brings us right to the famous snap, touch number 2. If the insect takes another step and brushes a hair within that 20-second window, a second electrical pulse fires. That second wave of calcium stacks right on top of whatever is left from the first wave. The tide suddenly rises past a critical threshold, breaking the line. The timer's beat. The plant has its proof. In a tenth of a second, the jaws interlock and the trap slams shut.
Now, you'd probably think the story ends right there, right? Predator catches prey. Game over. But actually, right now, the closed trap is merely a cage. It's not a stomach yet. It's snapped into this curved cell holding the insect inside, but it hasn't spent a single drop of digestive energy. It's still a fake-out. The plant is incredibly skeptical. It needs to verify that it didn't just catch a random piece of debris that happened to hit 2 hairs as it fell. Closing isn't eating. The plant is still counting.
So here comes touch number 3. The insect is trapped behind those interlocking bars, and naturally it absolutely panics. It starts struggling, thrashing around inside the cage, and as it fights, it inevitably brushes against those trigger hairs again. Pulse number 3 fires. This third electrical signal is the definitive proof of life. It tells the plant, without a shadow of a doubt, that whatever is inside is alive, moving, and absolutely worth spending energy on.
As that panic continues, we hit touch number 4. This fourth electrical pulse triggers a massive internal chemical shift. The plant begins producing a specific hormone, often referred to as jasmonate, which basically acts as an eat signal. This hormone commands the physical structure of the plant to change. The edges of the trap begin to seal tightly together, fusing the open spaces between the interlocking teeth. The cage is literally transforming, with the walls closing in to make a watertight seal. But wait, the acid hasn't been unleashed just yet.
Which brings us to the absolute point of no return, the dreaded fifth signal. Up until this exact moment, the plant has just been preparing. It sensed the touch, remembered the touch, trapped the prey, verified it was alive, and sealed the room. But it is this fifth agonizing brush of the trigger hair that flips the final switch.
5 literally equals digest. On that fifth touch, thousands of tiny microscopic glands lining the inner walls of the sealed trap suddenly switch on. They flood the chamber with a lethal cocktail of digestive juices, powerful acids and enzymes strong enough to completely dissolve an insect from the outside in. The cage is no longer a cage. It has officially become a stomach.
And honestly, here is the most horrifying detail of the whole shebang. The plant doesn't just stop at 5 and call it a day. It actually counts the struggling. The harder the prey fights, the more electrical signals fire. And the more signals that fire, the more digestive enzymes the plant pumps out. It literally dials up its digestion strength based on exactly how hard the prey fights. Over the next week to 10 days, it absorbs everything soft. Finally, the trap reopens, completely resetting itself, and drops nothing but a hollow, empty exoskeleton right onto the bog floor.
So if we step back, all of this builds into this incredibly clean logic flow of, well, brainless chemistry. Step 1, electricity senses the touch. Step 2, that electricity creates a physical calcium wave. Step 3, that leaking calcium acts as a perfect short-term memory timer. And step 4, a running tally of these signals drives a complex series of decisions: when to close, when to seal, and when to digest. There are no thoughts, no mind, just an incredibly elegant chemical program running quietly in the background.
You know, perhaps the strangest part of this entire mechanism is just how recently we actually figured it out. I mean, we've known about the Venus flytrap for centuries. Charles Darwin himself was totally obsessed with it. But we didn't actually prove this exact counting mechanism until the year 2016. It was a team of researchers in Würzburg, Germany, who finally managed to wire up these traps and actually watch them count, chemical by chemical, in real time. We just assumed we knew how this simple plant worked, and we were missing this incredibly complex math hidden right beneath the surface.
Which really leaves us with a final, kind of haunting question, doesn't it? If a plant, a simple organism with absolutely no brain, no neurons, and no mind to speak of, can keep a timer, remember a touch, actively count to 5, and make calculated decisions based on cost and energy, what else out there in the natural world is keeping score, while we arrogantly assume nothing's home? Thank you so much for joining me for this explainer. Keep questioning everything you see out there.